Hi math class. Today we're just going to do some examples. I want everybody getting comfortable using their calculator. So this first example I've set up, there's not even a context. I'm not trying to confuse you. There's no growth of a tree or depth of a tidal region or price of anything. Just a function. Okay, so I've given you a function there. It's a cubic. All right, all the terms. It's laid out for you. All right, some of these things we can answer right away without doing too much work. Some of them we're definitely going to need our calculator. It goes down to F. Yeah, there we go. So let's start by doing the degree. Remember, the degree is the highest power of x you see. The degree is 3. Okay, I already mentioned it's a cubic, and that's true. That's what a degree 3 polynomial is. Okay, the y-intercept is the value of the function when x equals 0. It's always just the last number here. Okay, it's actually going to be negative 2. And that's going to be true for every polynomial. Whatever the constant term is the y-intercept. To find the x-intercept, I don't think we can delay graphing this any longer. So we're going to have to put this into our calculator. Okay, so I'll do it off screen. Okay, now my window settings, I always set it back to default, which is negative 10 to 10 in the X and Y window. Okay, just to help you out, if you aren't comfortable doing that, this is your window button. If you push it, sometimes we change the window settings, we're going to do it a lot, but this is what I call default. So negative 10 to 10 is X min, X max. That X scale just shows you where they put dots. It doesn't matter what you have that set as. And then y min, y max, negative 10 to 10. And this actually shows us the behavior of the graph quite nicely. Okay, we're looking for the x-intercept. There may be more than one, okay, but I think I just spoiled it. Looks like there's only one, right? It looks like it's right there, right where the graph crosses the x-axis. It looks like it's around x equals 4. It might be x equals 4. We might get lucky. If you hit trace and type in x equals 4, we did not get lucky. Y equals 0.6. Okay, so the x-intercept is not x equals 4. Here's how we can calculate it. We've done this before. Hit second function, trace, which is the calculate menu, and lots of good stuff is in here. If you're finding an x-intercept, choose 0. Okay, it says left bound there at the bottom. Make sure you push the left arrow until the little flashy thing is to the left of the x-intercept. Hit enter, then move your guy to the right of the x-intercept. Press enter. For guess, you can just push enter again, or you can move it somewhere in between. Okay, let's see what we get. Our x-intercept is that value of x there, 3.875. Okay, let's finish this up. Question D asks for the value of f at x equals 1.5. Whenever you see that, you can just do trace, because you're finding a y value. So if I trace and then type in 1.5, enter, the y values that we're looking for looks like negative 2.81. All right, question E asks us for the value of x that makes f of x equal 5. And I've mentioned this in our previous video. When you're looking for a value of x, that's where you have to do an intersect. Okay, and I think that's what's going to cause us the most trouble now because it has the most steps. But I'm hoping you're starting to get a handle on that. So to do an intersect, we want to know where this graph equals 5. So it's going to be somewhere over here. But to get it exact, you hit y equals. All right, and you make y2 equal 5. Hit graph, and now there's a horizontal line, and you're looking for where it crosses our original curve. To do that, Go back into the calc menu, second function trace, and you can probably guess we want to do intersect. Okay, first curve. A lot of times you can just hit enter 3 times. This time it would work, but I want to show you, like, you know, the best way of doing it. Move it pretty close to the intersection. It doesn't need to be exact. Okay, second curve. Move it close, guess, get it in between. Let's see what we get. Okay, it looks like it's saying 4.67. Great. The last thing we got to do is end behavior. Let me just show what the graph looks like again. And remember our quadrants. They start in the top right. 1, 2, 3, 4. This looks like it's a 3 to 1. Looks great.